Okay, hello guys, I'm Mahmoud. Uh, this session is sponsored by Chain of Education. I will be talking about, I will be your tutor for calculus in this lecture. Wow, we made it for lecture 10. In this lecture will be continuation of what we started in the previous lecture regarding infinite series. And in this lecture, we'll be talking about the integral test and the P-series. So the integral test is a test we use if we had three conditions. Just as a recap, you should remember that we already discussed that if the series is a geometric series, how to solve it, if it's a telescoping series, how to solve it, and how to use the divergence test or the nth term test in order to guess the convergence or divergence of an infinite number. Today, we'll be learning the integral test, which is a new method to guess the behavior of an infinite sum. So if we had an infinite sum an, the series an, and all terms of an are positive, and the sequence an is decreasing, and an is a continuous function and could be written as a function of n, then I can say that whatever value is does the improper integral f of n dn gives me, the behavior of the integral will be the same as the behavior of the series. Okay, and this comes from the fact that the integral is actually the sum of rectangles and as well as the series, which is the sum of terms. So yes, this is the integral test. All three conditions must be satisfied in order to use it. So as brief examples, I will solve one and keep another for you. So you see, we have 1 over ln n. All terms are positive. We have n ln n is increasing, then 1 over n ln n is decreasing, the reciprocal of n ln n. And we have a continuous function that is discontinuous at n equals 0 and at n equal 1, and they are both excluded from the domain of integration, then I don't have any problem. So this series, infinite sum, will be equal, have the same behavior as the improper integral from 2 to infinity 1 over x ln x dx. Okay, we've seen this before. It's easy to solve. We can use the substitution method. If we choose u of x to be ln x, then du over dx will be equal 1 over x. This means that this whole thing will be equal to the integral of du over u, and it will be equal to ln x from 2 to infinity. We should use a limit to evaluate this. However, it will be equal to infinity, right? Ln infinity is equal to ln infinity, and is equal to infinity. Hence, I don't mind ln 2. It doesn't affect my final answer. And the series is divergent because the improper integral is divergent. Take your time, okay, and try to solve the other example using the same method. The fact that we discussed before p integrals in the improper integrals sections, and it appears that if we had a series of the form 1 over n power p, we should call it the p series. Why? Because first we have that all terms are positive, right? So this is the first condition for the integral test. We have that 1 over n power p is decreasing due to the fact that n power p is increasing. So the second condition is also satisfied. And this is a continuous function that have discontinuity only at n equals 0, which is excluded from the domain. So the third condition is also satisfied. This means that the behavior of this series is the same as the behavior integral from 1 to infinity 1 over x power p dx. And we already know that this is a p integral, and for different values of p, We have different behaviors for this improper integral. For p greater than 1, this improper integral would be convergent, and for p less than or equal 1, this p integral would be divergent. Okay, this is all for today. I hope you enjoyed the session. It was a very brief session. Study well and have a nice day.